Okay. Now, anybody want to tell me what's the difference between what I'm asking you to present today versus the first week's assignment? What's the main difference? Well, the first one, remember I told you that in communication, right? In communication, the whole thing about this class, the reason why design is not something you can study independent of human factor is because how you make your design influence how effective or ineffective or how convincing your communication is, right? Now, with the first assignment, okay, even though it's just to play with interactive menu, if that were a real assignment, what would the emphasis be on? It'd be trying to convince or display your idea in the best light, right? It's got nothing to do about objectivity. It's like you dressing up yourself in the morning, okay? As long as you cover your top half and your bottom half and you have shoes, you're good to go. The point is you want to present yourself nicely to the society, to your friends, to your date or whatever, right? So the first one, when we talk about interactive design exercise, where, you know, I was asking you to do like cylinder or whatever, and then let's say you're selling a coffee mug or I don't know, okay? That's really up to you, really. It's artistic, right? And you're trying to convince the best light possible. The second week, when we go to data visualization or visualization of data analytics, yes, you're trying to make a point. Yes, you're trying to convince. And if you are selling a product, you're trying to do in such a way that convince the audience or the clientele that your product is better. But you have to have a very high degree of objectivity, right? Otherwise, then we get to this misleading thing where, you know, you sort of like rescale stuff, okay? So objectivity is your first consideration. Once you got past that, yes, you can think of how to make it more effective. So effective communication is not effective to get your message across necessarily, right? If it's completely you're trying to sell a product, effective communication means you're trying to convince the person that your thing looks nicest. Okay, this thing would look nice in their living room, for example. Okay, that's fine. But with data, that must come second. Objectivity has to come first, right? Otherwise, you'll be guilty of manipulating all that stuff. Now, okay. So without further ado, I think you guys group one's good to go. Oh, 11. Good. So today, what you have is about maybe 5 minutes. Now, the idea here is to say why. Okay. Okay. You don't come up and say what. You know, say this is a graph of A versus B. That's the what. Okay. We drew this by download this file and use this function. That's a how. Okay. I don't want to hear that. Well, a little bit, just the beginning. But I want to hear the why. Why are you choosing this? Well, first of all, you know, nice to know why you're interested in this data set. Okay. But certainly why you made the parametric choice. Why do you make the axis this long? Why do you partition it so finely or not so finely, so crudely? Why do you use color? Why do you choose radial axis plot as opposed to bar chart? Why? Right? So I'm going to be grading you, well, obviously on how much work you did, but certainly in terms of presentation, I'm not interested in, you know, what is this? What does it mean? Okay. If you did a good job, what it means should be obvious. Remember, because I told you that data analytics comes in 3 levels, right? The level that I cover in my course goes from you look at the data, you visualize it, you get the picture. The second level is you have to feed it through statistical tests, you know, some algorithm, mathematical formula to get a conclusion. A third level is maybe you feed it to an AI and you get some insight. Okay, so your job here, if you did a good job, you don't even have to, you almost don't have to explain. It should come up and say, oh, wow, I get the picture. Okay, but never mind. You can, this is your first exercise. So obviously you have to do a little bit of explanation. So a little bit of what is this, what is that is okay. But what I'm looking for is why. Your choice, you made this axis. Why do you plot X versus Y? Why do you not put Y versus X or whatever? Okay, all the why. And it'd be nice, although I'm not counting on this. But remember, when you guys interview for admission, you're very proactive. I would like to see you proactive with your friends. Just talk with your friend, discuss with your friend. You know, so I don't have to be the one asking why again. So you see, oh, this you're using two variables. One is yellow, the other one is dark yellow. Why? Is that an inkling or suggestion that the darker, the higher the value, or just different? Again, remember, ordinal, nominal scale, right? Nominal scale means two colors are different. Ordinal scales mean not only are they different, it conveys a sense that one is hotter than the other, one is longer than the other, one is more dangerous than the other. Okay? Okay, right. So let's do that for 8 minutes each. That would give me about 45 minutes to an hour to cover one more aspect of visualization, which is a good blend of pure design and data, because it is displaying the data, but in a way that conveys sort of like a nice picture of what the social network looks like. And I think I would imagine that's quite relevant to you guys. Okay, group. Okay, I'll let Dimitri be the master of ceremony.
Okay, first group.
You do the timing. Okay, group 11.
Group number 11.
We clean the call on the net. You have extra mouse for this guy. Anybody needs to run for a mask?
So test. Okay, so okay, so we from group 11, and today we're going to present the data about the UK unemployment rate and the GDP. So as on the table, I have to mention first, the data we should have chosen is the UK unemployment rate compared to the GDP, which is that for 60 data. As we can see on the graph on the right, we have plotted the unemployment rate and the GDP into 4 groups because the data is repeated over and over, like from 1955 to 1958, and it repeated and can be divided into 4 groups. Okay, so and we decided to choose the blue one as our main data that we're going to analyze today, because it's mainly that it is usually that for the GDP is to increase if the unemployment is lower, right? However, for the blue one, as you can see that even though the unemployment is increased, the GDP continues to increase. Therefore, we have to decide to choose this data to analyze it.
Okay, for the second page, we will be introducing the unemployment rate corresponding to years. So the y-axis is the unemployment rate and the x-axis is the years. But however, the years we divided because there's 4 quarters in a year, so we didn't use the number of years. Instead, we used the number that correspond to each quarter. For the graph, we use a line graph because by using the line graph, we can see that the trend of the unemployment rate have been increasing very quickly throughout the years that we have selected. As you can see, for the first year, in 1955, the unemployment rate decreased slowly. However, when it reaches 1956, the graph starts to incline, and then 1957, we can also see a spike in the graph, and after that, there's a sharp in unemployment rate. So what do we get from this graph? We can see that there's a period of economic growth from 1955 to around 1956 because the graph declines, and however, after that, there's a economic recession throughout 1956 to 1985.
Okay, so for this, another thing that the GDP per capita can indicate is the economy expansion. So for this graph, it shows the mean GDP per capita from the first quarter of 1955 to the fourth quarter of 1958. So there are some indicators that you can see from this graph. As you can see from the first one, 1955, there's a significant growth rate from the previous year by 4.4%, which you can say that the economy is expanding. And then in the next 2 years, in 1957, there's a slight decline in the growth rate, but still goes in a positive direction. So this can tell us that there's a slowdown in the economy expansion. And in the fourth quarter of 1957, there's a slight uptick of the growth rate, and it goes by the positive way to 2.7% from 2.2% from the first quarter. And last but not least, in the 1958, there's a decline, which goes down to the negative side of direction, which you can tell that there's a recession from this. Then after the second quarter onwards, it gradually increases in the stable growth rate.
So here are 6 factors that might affect GDP growth rate per capita. So the first one is the productivity. If the productivity increase, it will affect increase in GDP growth rate and economic growth. And next is the investment. Some country uses put their investment on technology to boost their productivity and therefore increase growth rate and GDP. And next is government tax regulation. An increase in tax can cause the citizen to spend less money, and therefore this will decrease in GDP per capita. And for natural resource, some countries have natural resources such as oil and gas, which will affect an increase in GDP. And for demographics, some countries are experiencing aging society, which causes the GDP to be lower. And lastly, for global economic conditions, fluctuations in exchange rate can cause a fluctuation in GDP each year. That's it. Thank you.
Okay, go ahead. So we'll do this thing. You present 5 minutes, comment immediately for 3 minutes. Now, it'd be more fair if I let everybody make the presentation and I come and make comments at the end, but I think we kind of get lost. So I think it's fresher to do this. So even though it's not so fair for the people going first. Okay, so show me the slides again. Yeah. Right. So from page 1, you right there. What's this number? What's his number? Can you see? Nope. Right. So once again, same thing with the first assignment. I'm sitting here. I have tough time, but maybe I'm older than you guys. But even you guys are at the same age. You can't see that far, right? So this number here. Okay. Now, there's a difference between big print and small print. Okay. In some graph, you get the big print to get the message across, but you do need the fine print because this serves as a document. For example, this number can be made bigger, right? So that people can see it from the presentation, but there has to be a small number here or a small description say, where does this come from? Now, you in the back don't need to know where this data come from, but you need to know that it's on the slides so that this is not some number that just pulled magically. So it has a real source, it's legit, it's from Bloomberg, it's from, I don't know, okay, Bank of England economic data of which year. So there's a fine print, that's fine. So not everything has to be seen at a distance, that's not my point. But certainly the things that get the message across has to, right? Okay. Maybe go to the next page. So this is one of those things where you're having too many things in the same slide. It's fine. I like the idea of timeline, but once again, timeline. Okay, first of all, what is your friend trying to say right now? The whole story. Remember remember my mind map, right? What are you trying to communicate? You're communicating the extent. You trying to communicate correlates, meaning things are correlate to one another. You're trying to communicate differentiation. This is different from that. You're trying to communicate anomaly. This is abnormal event. What are you trying to communicate? All right. So those things should come first, right? You should be able to say which line from my mind map you're trying to do. Okay. You may be trying to communicate a few things, but the first thing you're trying to do. In this case, my guess, because the presentation is not that clear, you're trying to present how things are similar or go together, like unemployment with productivity or GDP with unemployment or something, right? And that's why you're trying to do this kind of correlation between X and Y. You're not trying to say that X is better than Y. You're not trying to say that X is abnormal. There's an anomaly detection here. You're trying to visualize X and Y has relationship. Okay? So the first thing you should say is that my slides, my decision is based on how well I can communicate relationship. That's the first why I'm looking for, right? I'm trying to make relationship. Now, the relationship should be embedded or obvious in the line, which again, I think is too thin, but you guys see that, right? Too thin, too small. I have no idea, okay? And the axis is, again, it's not that clear. It should mark with the year, even though it goes by quarterly, right? I shouldn't have to say number 15 is the 15th quarter starting from 1955, right? Should I do that math in my head? Should I say 15 is 15 quarters after to 1955? Or should I see, well, that's whatever year that is, whatever that quarter that is, okay? So first thing, the why that you come to your head is, I'm trying to communicate relationship. And this relationship is motivated, let's say, by, what's the most important variable here? Maybe GDP is the most important variable. Are you trying to say that GDP relates to unemployment? GDP relates to productivity? GDP relates to whatever effects, okay? So make that clear first. Be very conscious, and then tell us. Again, I'm not interested in the UK economy at the moment. Now, I'll give you a hint, not a hint, a suggestion. Graph should dominate. The graph should be big, okay? Because the idea here is that once you see the graph, you get the picture that there's a rise, there's a dip, there's a recession here and there, right? The timeline should be the second thing that comes up. So perhaps maybe the first slide is just the line. The second slide would be that line with notable feature, namely the timeline, point to it, right? So I'm assuming that the fourth quarter of 1957, you are probably pointing somewhere there. Okay, make that link, okay, make that link. Now, how would you do that in practice? You just use a labeling function or something, okay? So some function has a call out, some point, this point has a call out and say, this is interesting, and therefore. Remember, go back to the picture I always say, carbon dioxide concentration in the atmosphere. It looks like this, and then the axis here is the year, and somebody can circle this with the box like that, right? And say Industrial Revolution begins. Okay, so again, this is a learning exercise. The more critical I give you, the better. I'll go to the last one. This thing I think is good. It helps organize the subject. So I would lead off with that. Okay, this sort of like gives your audience your game plan. I'm going to talk about, let's say, what drives GDP. And these are the 6 things. So let's look at 6 things that possibly correlate with GDP. I don't know, something like that. Okay, good. It's good learning. Okay, next group is?
Group number 1.
Know why I put a lot of emphasis on putting your mask on? Actually, this is not even just COVID. I don't know if you've been to Japan, but in Japanese culture, you walk around, this is way before COVID, right? People wear this a lot, okay? They're not wearing this to protect themselves, right? They're wearing it to what? Protect the society from your own sneezes, okay? And it's one of those things where it says that your comfort means less than the comfort of the society, okay? So that's why, you know, I'm an advocate of that. Yeah, it has to do with COVID, okay? But certainly it has a little bit more to do with what's called human decency or human courtesy. Are you listening? Okay. แค่ใส่ครับลูกลืม Okay. Same thing with dress. You know, you guys, why do we need to wear shoes to college? Why can't we say wear sandals and thongs or whatever? Okay. It's saying that you're more willing to be uncomfortable, right? And that's just a sign of respect. Okay. So I interview hundreds of data scientists, but I don't tell them this, but actually look at the shoes they wear when they come to see me. Okay. If they wear sandals, I don't care if they know how to do Python better than, because my staff are better than them anyway. I have to train them. So none of them are geniuses. So if they come to me with sandals, they don't get into my team. Simple as that. Same with mask. You lost your
จะจอย
I think I'll try this one too.
Tell you what, okay.
กูจะขำค่ะไม่ได้ ชื่อเปลี่ยนแล้ววันไม่ใครเนี่ยมึงนะ ประชุมกี่โมง Okay.
Hello.
Sorry for the late technical problem. Okay,ค่ะ. So hi guys.
So today we will try to explore the human cognitive factors using Mathematica. So first we divided it into steps into using the Mathematica first. And so the first step is to see all the statistics first and select which one we're doing, which we're doing the cabbage example data set. And then here we find the dimension of the statistics to know how many information there are. And then we found out the column heading in order to know what variable and what information we're trying to make sense of. And that is cultivar, date, head weight, and also VITC. And then we put data set into column for easier visualization, as you can see there. And then this code is to show all the statistic of the cabbage in a list format. And then this is the first graph that we have, which is plotting the head weight and the ascorbic acid. And this is the first graph for day 6. We group the data by date, and there is day 16, day 20, and day 21. That's the first graph, and the second graph, and the third, and this is the altogether graph. But if you go back, then you will see that there is a negative correlation between everything. And
okay, so as you can see, this graph illustrates the relationship between the cabbage head weight and its ascorbic acid levels. And from this graph, we can see a negative slope indicating a negative correlation between the two variables. This means that once one variable is changed, it will have an impact on the other. In this case, if the head weight of the cabbage is increased, its ascorbic acid levels will also decrease. To sum it up, our analysis revealed that there is a negative correlation between the head weight and ascorbic acid levels. This conclusion is also in line with online research studies that we have found. Our visualizations accurately show this relationship, and this insight could be valuable in fields like the medical research and also the food industry. And the reason why we choose to use the scatter plot is because that it will allow users to identify any possible links in terms of relationship between two sets of variables. A scatter plot is often used to provide visual and statistical meaning to test the strength between two variables. Thank you.
Okay. Very good. So go back to the slides. Okay, I'll make comments. Go to slide 1, Lelo. Okay, good. Now, for example, okay, you in the back obviously can't see this, but this is okay because the idea here is to communicate that there's a lot of them, right? So sometimes you deliberately make things not readable to communicate the fact that there are plenty. So if somebody say, oh, I'm just looking at the data sample, how many could there be? Maybe there are 4 or 5. Oh no, there's plenty, right? So that's what it says. That's what it says. So that's fine. So that would be an okay use of fine print. You can't see, but you get the impression because you're trying to communicate that there are many data sets, more than you can count on your hands. Okay, so yeah, you can't see it either, but in this case, it works because it's saying that too many to count. Okay, fine, go. Next. Okay, same here. This little thing here, these are little fine prints. Nobody needs to know the code, but they're just saying that, well, this is the step that we did, and this is what the code would look like. So it's a little bit like a fine print where it's a document so that somebody can, in theory, replicate. I do this as well. So I have a big heading, I have a line, there's a presentation where I make a similar kind of parallel coding between Python and Mathematica. So I do a little window that say, actually 3 windows. One window is what I want to do in English. Second window is how this is done in Python. Third window is how it's done in Mathematica. Now, The window that say what I want to do, well, that's meant to be legible because I want people to know what I want to do. The window that contains Mathematica and Python, it's a little bit small, you can't see. But from a distance, you can definitely see that it takes 1 line of Mathematica to do 5 lines of Python. That's all I need to say. That's all I need to say. Now, people can replicate this by looking at the details. What are the codes, right? But the message that I got across in that slide is, this is what I want to do. Mathematica takes 1 line, Python takes 7, right? So those are the fine print. You don't have to see all of that. Okay, fine. So that's good so far. Next. Okay, that's a little bit too much now. Okay, next. Now this is a waste of space, right? There's a lot here. I mean, this is good enough for little puppies to run around in. You don't want that. That's a waste of real estate. Okay. Now with list plot, now this is not a data analytics class, so I'm not asking you to fit the data. But the simple things like this, if you want to communicate, it's good to learn very basic linear fit, right? Just because you want to draw a line through it. Okay. Now, short of this, maybe you can use what's called a list line plot. There's a line that goes through them. So that might give you a little bit more picture, right? It's sort of like connecting from dot 1 to 2, 3, 4, 5. And that gives you a little bit of a story. But I would imagine that linear regression or linear fit or quadratic fit is not beyond BASI student. Okay, so even though technically it's analytics, it would certainly help the story a lot more, right? Okay, especially if you can say that, well, it looks linear, but a better way to think of it is that it's actually slightly curved upward. Now that you can't see from data unless you fit it. Okay, so basic analytics help. Okay, analytics and visualization are like buddies. You get visualization. Visualization helps you determine the analytics you apply. Once you get the analytics apply, extract all the information, you use visualization to communicate the result. It goes back and forth. Okay, it goes back and forth. So yeah, I'm not asking you to do advanced analytics, but if you're doing something like this, fit a linear line or quadratic on it. Okay, it would be a lot nicer to get that. Okay, good. Group 17.
Group number 17.
Okay, hello everyone. For our cognitive human factors, thank you. For our cognitive human factor in design assignment 2, we decided to share our journey on our data analysis and visualization of the Boston housing data set. So first, we would like to share the outline that we're doing for the presentation today. We'll try to be as quick as possible. First off, let's start with the background of our data.
So the Boston housing dataset is a well-known dataset in machine learning and statistics about house pricing in Boston, including various features, including crime rate, average number of room per dwelling, and distance to employment centers. So the description of the data is housing values in suburbs of Boston, and the dimensions of the data includes 506 rows and 14 columns.
So for the data preparation, we decided to cut out two set of columns, which are the Charles River and the residential land over 25,000 square meter, which is because the data is Boolean and percentage, which might not be suitable for our analysis. So here is our set of data that we have chosen. And we found out that the data is normally distributed, but it is only a bit slightly leftly skewed.
So the data analysis tool 1 is the correlation matrix. So the darker colors indicate a stronger correlation and the light colors indicate weaker correlation, meaning that the blue indicates negative while red indicates positive. This is the basis that we use to help decide whether some variables have any relationship and correlation to 2 to 3 columns.
So some more tools that we use to analyze, we decided to make this interactive for our users who might be looking at this data later on to be able to select the data parameters and the clustering configuration that we're going to be using. So let's say, for example, we can select the data parameter of how crime rates in the area relate to the population of Black people according to Crime and Black. So the first tool that we're using for this is two-factor data, is through using clustering. So when we cluster and we found around 3 clusters, which is the average that we usually start off with, we see that there are some correlations regarding, okay, let me try another one. So for example, the distance from the city center and crime rate. Here we're gonna see that the further away we are from the city center, the number of crimes actually decrease. So most of the crimes are mainly around the city center. And if we look at the scatter plot and linear regression, we also see the same thing. We're gonna have a summary later on what other insights that we found, but all the tools in this page are used where there are correlations between 2 variables. And we can also use a contour map to see how our variables are spread out amongst our data set. Now, up next, Santa's going to be talking about what do we do when we want to use analysis tools with 3 parameters.
Okay, so based on the heat map earlier, we know that some of the data have correlation with each other, but sometimes we have also outliers or the third factor that might impact the whole data. And that's why we use a 3D scatter plot. This is because in a normal scatter plot, it only compares the variables of X and Y. So you might be only able to gain insight and pattern based on those 2 things. But if we combine and create a 3D scatter plot, we might be able to interact with the graph more and find further insights or trend that is not visible in a 2D scatter plot. And for this 3D scatter plot, we decided to use the data column of median house value, lower population status, and also the crime rate, because we believe these are the 3 things that could determine, for example, in the real world situation, house pricing. And the next one, when we have multiple variables, we can also use bubble chart as well, because this will help you digest the multiple variable into a more readable visualization. For example, in this case, we use the distance from I'm sorry, we use the median house value, the lower population, and also the average room per dwelling. So the warmer color indicates higher value, and the cooler color indicates lower value. And the size of the bubble can also be the third factor that decide the intensity or the overall value of that factor that influence the X and Y variable. And a famous real world example of this is the website called Gapminder, where they tells you the data about the world, whether it's fertility rate, death rate, into some sort of bubble chart, and you can visualize the data better.
Okay, so finally will be the summary. So right then we have you be able to select the parameters and identify any relationships that you want to identify. Now let's see the summary of what we've found. First up will be from Santa.
Okay, so the first summary that we found is by comparing the data between crime rate and the distance from city center. There is a negative correlation to this, meaning that as the distance is further away from the city center, there will also be less crime rate. This may be due to the fact that in the United States, where the data set is from, only rich people are able to afford city outside of the place outside of the city. Hence, the lower status economic population are not able to go there. So crime rate does not tends to be lower as the distance from the city center is further away.
So for the bubble chart, the relationship between the variable LSTAT, MEDV, and crime, that we see that general trends are decreasing when MV and LSTAT are increasing, which suggests a negative correlation. Additionally, we can see that the bubbles tend to be longer in lower left corner chart, which suggests a positive correlation. From the chart, we can see that there's a strong correlation between LSTAT and MEDV, meaning that the percentage of lower status population increases. The median value of owner-occupied home decreases. We can also see that areas with higher crime rate tend to have higher percentage of lower income population. Overall, the bubble chart provides us visual representation of relationship between these variables.
So the next one will be a 3-variable comparison. So we found out that with a lower status, lower percentage of lower status population increases, the value of homes that they're actually living in is decreasing. And with a decreased value of home, the number of rooms in each housing also decreases, suggesting that people of lower income actually live together without any separate rooms.
So the fourth one is the relationship between the median household and the nitric oxide concentration. And this scatter plot show a negative slope, which means that as the nitric oxide concentration increase, the median house value decrease, and the R square value is relatively low, which means that only the small proportion of the which means that it explains only a small portion of the data, and it also explains that there may be other factors that affect the relationship between these two data that the linear regression model doesn't demonstrate.
Yes, and for our final point, we might have recalled from the correlation matrix earlier on that there's a correlation between the radial distance from the city and the tax rate. However, once we look at the contour chart, we realize that this correlation only exists because our data is mainly concentrated around places that are not really far from the city. So although that our correlation matrix may say there's a higher correlation, we have to beware because our data actually shows otherwise, that we don't have a variety enough of a data set, and that's all of our info. Yep.
Okay, เดี๋ยวอยู่ตรงเพราะเราเดี๋ยวต้องเลื่อนขึ้นเลื่อนลง Okay,ครับ, very good. Now, this group did a little bit of analytics, which was not part of the assignment, but good on you. You remember last week's data, right? The data set that I showed you that I did the axial radial axis plot, right? That one came pre-clustered. In other words, I already did the clustering because, again, this is not data analytics class, so it's already clustered. But in this case, it didn't come in cluster, so you had to go extra step to do the clustering. So that's good. But again, visualization comes before and after data analytics. Visualization allows you to play with the data and get a feel for the data. You start forming hypotheses, starting apply statistical tools and so forth. Once you get the result, you communicate back to the larger public with visualization, right? Now, I want to point out a few things. Very good. Let's go back to the one with scatter plot just now. Okay, see, scatter plot, right? Scatter plot. Now, the previous group, you saw a sort of like a relationship, okay? This one, you also saw a bit of relationship. Now, there's a line through it, so that looks good. That looks like a linear fit. But what else is different about this plot compared to last group's plot? First of all, it has a lot more data points, but more importantly, even though you observe there's a downward trend, there's a lot of variability, right? Okay, this is what I mean by look at it, you get the picture. You think there's a downward relationship, but the picture is also dominated by inherent variability. Now, in data analytics, this would suggest that in the second step, when you do the statistical analysis, this downward slope may not be statistically significant. Okay, that's part of data analytics. But even if you didn't know data analytics at all, okay, and this is simple data analytics like normality and R square and T statistic, very basic high school stuff. But even if you didn't know this second level of data analytics, this statistical measurement or statistical testing, look at this, you can say two things. It has a downward trend, but don't make a big fuss about it. Because even though there's a downward trend, there's also inherent variability in the Y that has nothing to do with X, right? So yes, I can see the downward trend, but it's not that deterministic. So this is why between two variables, scatter plot tells you, first of all, you should ask yourself two things. Well, the big question is it completely random? There's no relationship. Let's say there is relationship. Is that relationship the main determinant of value of Y? Or is it, yeah, it's helpful. In this case, it's only a little bit helpful. It's not that helpful, right? Because even if you know X, 0.7, there's the variety of Y could be, okay? So this tells you two things. A, Y is a function of X and a lot of noise. That's all. You can't do anything more about it. Or B, Y is a function of X. And the thing that you think is noise is actually dependent on other parameter, other variable. Let's go find it. Your job is not done. So maybe Y is a function of X is not good. Let's find X2 to help. Okay, so this is why you look at it, you get the picture. Now, the person looking here is not necessarily the end user, it's more like the data analyst. Look at it. So the user of this case would be the data analyst. Say, hey, I should do something. I should find a third variable here. Okay. Now, if you try to find the third variable, fourth variable, fifth variable, you try to find everything in the possible universe of data, you couldn't find anything at all. Then this would be the final picture to the public and say, you know what? Y is so random. The best variable I can help you with is X. And even that's not doing much. Right? But of course, if this were a real presentation by data analysts, you back it up with t-tests and whatnot. So this is a good point of demonstration of looking at it, get the picture. It's almost pre-conclusion. Now, the other thing you should look from scatter plot is not just whether or not there's a relationship, there's a lot of noise, but also the shape. And this is a little bit subtle. So if the noise is not that big, or if the variability is not that wide, then you might be able to ask yourself, is it linear versus nonlinear? That's something else. Okay? So that's good. Now, let's go to the bubble chart. Bubble chart, bubble chart. Let me ask you this, and you can answer this in exam. How many variables can you display on a scatter plot at once? How many dimensions? Actually, you can do 3D scatter plot, right? So that's 3. But this, even though I didn't mention before, but it's good that you came onto it, you actually have dimension of colors and size. So theoretically, I can squeeze 5 dimensions. Theoretically, I can squeeze 5 dimensions: X, Y, and Z or Z. Color and size. Now, that's not always doable. And this has to do with which bullet point from my mind map? Numerosity. Numerosity of your data. If you have 100 data points, you can afford to depict individual colors, individual size. But if you have 2,000 data points, you can do X, Y, Z. But if you distinguish by color, well, maybe. Can you distinguish by, it's very hard. Okay, it may be possible, but chances are you wouldn't be able to do that. So this is good. This is a kind of upper limit. Now, unfortunately, you went to color and size before you went to third dimension, right? In fact, colors and size is not as good as axis. So exhaust your axis first. You see, you have one more, right? Unless you're trying to communicate the size of whatever. Sometimes you have that meaning. Okay, but most of the time, unless you exhausted all your numerical axis, don't go to colors or a bubble yet. Okay, but I can see this could be something like the value of the house or something. I don't know what it is. Okay, and the color could be used for maybe non-numerical value like nominal scale. For example, you can have ethnicity, and then that case that would make sense, right? So this is numerical. This is numerical. The color is ethnicity, right? Because it's not ordinal, it's nominal scale. And then the size of the bubble could be literally maybe the size of the property. I don't know. Okay, so it has that semantic. Remember this discussion right here. This is exactly the crux of what I've been trying to do. Okay. Designing your visualization of the data is all about making all these decisions. Okay? If the colors represent ethnicity, and I told you, make the z-axis ethnicity, would that make sense? That's not good, right? Because what you're going to do, put white on top and then black below, or Asian on top of black and white. That's no good, right? That's no good. So you don't want to put ethnicity on a scale that ranks. So color would be better, okay? So these are all the consideration. These are all the consideration. Finally, go back a little bit to the matrix plot. I have to say that maybe you use default scale, right? The darker being red and the negative being blue. I would imagine Okay, I would imagine that I would put blue as a positive and then red as a negative, or green and red. Okay, okay, something like that. That might make sense. In which case, the more blue, the more positive. So on the diagonal will be all blue, right? Whereas here it's large and negative. This would be like red. So blue, red, something like that. That might make more intuitive sense. But in any case, shouldn't just do this and let people look at it. You should have legends on the side, right? So if you decided that red is +1 and blue is -1, there should be a strip of color that tells you how to do it. Okay, because right now I can't. Now I can guess. You know why I can guess? Because by definition, diagonal is 1. So I have to know that maximum, that's red is 1. But in other contexts, that's not correlation matrix, you have to guess. Okay, and in fact, today, I'll show you about social network exactly on this kind of picture. Good. Next group, 14. This is what, 17? This. Final point. Because they use Mathematica in slide mode, you don't have to go through the extra step of copying and pasting. Like the previous group has to copy and paste into the PowerPoint. This one you don't. However, you should keep a discipline because Mathematica doesn't fix the page width. So it doesn't look exactly like a PowerPoint slide. So what you should do is just chop it up into many slides. So people are more familiar with that.
Hi, we are group 14. We are doing a salary comparison between full-time job and part-time jobs. So our purpose is to compare the salary of full-time job and part-time job to see which one earn more. So the step 1, we distinguish between full-time and part-time job by observing that a value of 1 indicates full-time, and the value that less than 1 indicates part-time job. Second, after we separate full-time and part-time, we group together people who work the same job. And the third step, we calculate the average salary for each job, both part-time and full-time. So last step is a plot graph. Here is the code for full-time job. To find the average salary of the job, the full-time job. And this is for the part-time. As you see, there's a comparison of the part-time and full-time salary. As you can see, the full-time has earned more salary than part-time. And in this scenario, we should bar graph because it can be used to indicate jobs and salary clearly by labelling salary in the y-axis and job in x-axis. The graph will clearly represent each job and the amount of salary made. On the other hand, line graph would only show the amount of salary and would require many graphs to accurately present this data set. Thank you.
Okay. By the way, one more comment about the previous group. Your interactivity, you do the setting here, and then couple of lines later you do the graph. In a final polished presentation, right? I would make like a one panel, right? Like sort of like a manipulate picture, and then you just do that on the same graph. Okay. Now, okay, go back to slides. So first of all, by the way, I guarantee this is going to be on the exam. What are you trying to communicate? I'm just going to show you a picture, and then what am I trying to communicate? What are you trying to communicate here? The difference, right? Exactly, comparison, one versus the other. Okay, so let's go to the bar graph. Okay, first of all, it's a little bit too thin, but that's okay. You can make it larger. It's not a big deal, right? But one of the things I would suggest, one of the most, I would say, go-to tools for comparison is histogram, right? So if you have two histograms, one in blue, one in red, right? Blue for full-time, red for part-time. And the fact that they are separated in histogram suggests that the means are different. And you guys did this in Statistic 101, which is difference in means, right? Have you guys done that? Alpha, beta, power, probability type 1 error, probability type 2 error. You guys remember that? And those concepts are rooted in drawing two bell curve. And bell curve is an idealized parametric function that models real life histogram. So I would imagine if you get a data set and you're trying to compare two things about it, my best bet would be go to the histogram of that dimension. Okay, so this is a little bit like, this reminds me like plotting it to see what the data looks like. You will be using this. You would use this to form your hypothesis, your whatever, and then maybe you do a histogram, then you would show that. Yeah, so this is more like a looking at data exploration rather than visualization of the final product. Okay, good. What's four?
Hi everyone, in this presentation, I will be explaining the mathematical code that generate a scatter plot of animal body weight versus the brain weight and allow the user to interactively explore the data. The code begins by loading example data from the Mathematica built-in dataset, specifically the animal weight from the statistic collection. The code then extracts the column heading, body weight, brain weight, and animal name from the data. Next, scatter plot of the data is created using the list plot function with the plot style option set to a point of 0.02 and the plot theme option set to detail. From the frame label and plot label option are used to label the X and Y axis and to provide a title for the plot. The resulting plot is assigned to the variable scatter plot. A scatter plot is appropriate for this example data because it allows us to visualize the relationship between two continuous variables. In this case, is body weight and brain weight for each animal in the dataset. By using body weight as x-axis variable and brain weight as the y-axis variable, we can easily visualize the pattern of the data point in terms of the relative size of these two quantities. For example, we can see whether animals with larger body tend to have larger or smaller brain, and whether there are any outlier or other interesting features of the data. The code then creates an interactive plot using the manipulate function. The list plot function is used again to create the plot, but in this time with a smaller point size of 0.015. The epilogue option is used to add text label to each point, displaying the corresponding animal name. The plot range option is set to allow the user to adjust the X and Y axis to limit using slider. The manipulate function also creates a row of text that display the name of currently selected animal and allow the user to select individual animal and adjust. Allow the user to select a different animal using a slider. In addition, using a scatter plot with a manipulate interface allow the user to explore the data in more detail by selecting individual animal and adjusting the plot axis to zoom in on specific range of data. This can be particularly useful to identify outlier or unusual data point that may not be immediately apparent in the full plot. This interactive plot is a powerful tool to exploring and analyzing data as it allows users to quickly and easily compare different data points and visualize relationship between variables. Finally, the show function is used to display the interactive manipulate plot side by side. Thank you.
Go ahead, Kap. Okay, comment not about the work, but about the content of the presentation. Actually, this is pretty good because this is what I'm looking for, the justification why you use this and that, right? You want to use this and you want to explore this and you have different options and so forth. Now, you saw right away that there was a little bit of a hiccup, right? You're trying to show the data, but it doesn't run. Well, here's the deal. You have to enable dynamic compute. Well, you have to execute, if you're going to use Mathematica as a live presentation, my suggestion is you execute all the commands before you present, okay? Now, this may not sound like a big thing to you, but it's a big thing to me because some of my demonstration involve optimization, involve data fitting, involve all this. If I'm going to show this to the clients and it's going to take like maybe even 3 seconds to run the algorithm, it interrupts the flow. So what I would do is compute everything already. So all the manipulate screen would already be up, right? All the simulation, all the optimization, all the numerical algorithm, it's already run. When I show it, all I need to do is just move things around and the data is there. Okay, so don't do it live, guys. That's a little bit risky. Okay, so interactive doesn't mean live, doesn't mean you're computing on the spot, except if you want to demonstrate how quick it is. Some of my optimization, for example, involve allocation of fund. I'm from investment management profession, so I do a lot of optimization in terms of selecting investment. And sometimes I want to show that this algorithm is so fast, I can just optimize live with 500 funds. But most of the time, that's not my point. So I would just run all the optimization before I get to the clients. Okay, so do that before the presentation. Good. Next.
Group number 9.
Good afternoon, everyone. And we'll be presenting about the Swiss banknote data. Okay, so this is our data that we chose. It's about the Swiss banknotes, the banknotes of Switzerland. And we chose this data because there's a lot of dimension and we think that we can explore more on the data. It's 200 rows and 6 columns. And these are the data. So first of the first section will be talking about the visualization that we try to explore more on and try on different techniques. And this one is the contour plot 3D. And we are trying to use this visualization to visualize the distribution of the banknotes in the space defined by 2 of the dimensions of the banknotes, with the contour representing the density of banknotes at different locations in the space. And this one is the list plot 3D. And what we did was like, first of all, we did like a basic list plot 3D, and we're trying to explore more on the interactive and manipulate by the height and the colors like these. And we are trying to apply what we discovered from last week and try to apply more on the graph. What? Sorry. And this is the box whisker chart. And what we are trying to do with this is we are trying to see the outliers of the data of the Swiss bank notes, and the points outside the whisker box are the outliers. And this visualization gives the good sense of distribution of the different measures of the data.
This code loads a Swiss banknote data set from the built-in example data in the Mathematica. extract the numerical data and store it in a variable called my data. This represents the feature of Swiss banknotes through the use of histogram 3D as a cluster. This code also loads a Swiss banknote dataset from example data, but the second line creates a list of points by flattening a nest table of X, Y, and Z coordinates, where the Z coordinates is the value of my data matrix at that point. This code creates a manipulate interface that allows user to adjust the value of height between 0 and 300. This value is used to set upper limit of Z-axis in the plot. The list point plot 3D function is used to create a 3D scatter plot of the data points, where the color of each point is determined by the rainbow color function. The plot is styled with no box and label axis, and the plot range is said to be automatic in X and Y directions, but have to fix range in 0 to high in Z direction. This code will create an interactive scatter plot that allows you to explore the relationship between any two measurements in Swiss banknotes dataset.
From the raw data, there is correlation between the length of the left, right, bottom, and top. So list plot is ideally suited for the data for this type because it allows you to visualize the entire pattern based on the axis. Looking at the graph, you can see at what range the data is classified as counterfeit and genuine. So for example, the left bottom, you can clearly see that if the length of the right is higher than 10 and the length of diagonal is more than 140.6, it means that the bank is a fake one. So in this way, you can clearly see the outlier as well, and also the path at what range the data will classified as genuine and counterfeit. So that's why the reason why we think that this type is one of the best choice in terms of data visualization, because you can clearly see the whole pattern in just by glancing at the data.
Okay, so coming to the last part, this code generates two interactive visualization of the data set, where the first one visualization is the 3D version of the scatter plot. This is created using the list point plot 3D, where it allows user to play with three chosen variable at a time. It allows user to kind of like compare length, top, and diagonal. And if it's not enough to distinguish whether the banknote is fake or real, the user can always move on to the next features and compare it more. User can choose the multiple color of their choice, representing the counterfeit and the genuine banknotes. And next is the 2D graph, which is kind of like similar to the one that my friend already mentioned before. However, this time we're dealing with only like two variables at a time. So the purpose of these graphs is actually for better visualization in terms of visualizing the data and also exploring relationship between variables and identifying patterns and differences in terms of distinguishing the fakes from the real ones. So thank you.
Jacob. Right. So I think in terms of story, in terms of telling the story, you were not giving the finished picture. You were sort of like taking us through what you went through, which is okay. But if you were trying to actually present the visualization, you would flip this around, right? You would actually start at, I'm looking at the banknote and I want to know what distinguishes red from black, basically, right? Black is genuine, red is counterfeit, right? So basically a binary comparison, taking into account whether or not all this other measurement, whatever, the length, width, or whatever, okay, can help distinguish, Okay, so it is counterfeit detection by eyeballing, right? Except you're not eyeballing the raw number, you're eyeballing from the last picture that you got. So the last picture is very good. Now, I want to show you what's not good. It's the previous pictures. And this is has to do with you choosing the right plotting method for the data. Okay. Now, in the beginning, you show example of, for example, if you have a contour plot and one axis is exactly the same, you're not seeing anything, right? You go to the, yeah. Oh, okay. This is a good one as well. Okay. For example, here. Okay. This looks nice in 3D, but do you need 3D plot? You don't, right? Because the other dimension is the same. Okay. So in this case, sometime, right? For newscasts or something like that, you might do this because it gets people's attention. Okay. But for serious presentation, people will say, why are you drawing 3D when 2D would do, right? So don't use more dimension than your data has. Okay. So this is a good point. So this would be a bad presentation if this were in your final product. But yeah, you were exploring this and fine, that's okay. Same thing with the contour plot, right? The contour plot, what's good about contour plot is this. It shows you that combination of x1 and x2 gives a very non-linear contour. If it's linear, the higher the x1, the higher x2. For example, y is equal to 5x1 plus 7x2. What's that going to look like? That's just going to look like a plane, right? If you do a contour plot, that's not interesting. It's just a nice smooth color grading. But if the function is highly irregular with bumps and valleys, look like a hill, contour plot is good for that. Okay, so if there's no inherent complexity or variability or nonlinearity, contour plot would just be a distraction. Okay, so I'm glad you saw it and said, well, that's no good. You don't include that in the final presentation. Good. Okay, Cap. Oh, she won. Okay, fine. 13. 1, 3, 1, 3, 1, 3. So,
Sure. Cool.
Okay, hi everyone, and this is group 13. And the data set that we have chosen is about the orange tree growth. And there are two main reasons why we choose it. The first one, I love orange. Do you guys love orange? Do you guys like orange? I think we all do.
Okay, yeah, sure. And the second reason?
And the second reason is that 3 of our 5 members of our group love about agri-tech. And that's the reasons why we saw a huge opportunity to apply the data set that we have learned in this class to our real world experience.
Yeah, how cool.
Yeah.
Okay, so we have some interested video to show you.
Don't you guys like orange? I think we all do, right? Okay.
Look tasty, right?
Okay, so let's start with our
Let's get into
presentation.
the work. So as every group, we start with the example data, right? And we go through like tons of data and we pick this one.
Okay, so the data that we have chosen is about the orange tree, which I love the most. Yeah, so the purpose of this data set is to show the time series of these growth rates of the circumferences of this orange tree. So the column heading will probably consist of tree, age, and circumferences. For the tree, we will show the index number of the trees, 1, 2, 3, 4, 5. And the age is the age of the tree in days since December 31, 1986.
We
And
haven't born
lastly,
yet, right?
yes, we haven't born yet. Okay. And lastly, the trunk circumferences in millimeter.
What is circumference mean?
Circumference. Okay. Okay. Okay.
Okay.
So we are a group of clever students. That's the reasons why we create 4 different charts for this data set. But at this point, I think we need your guys' participation to choose which chart is the best to show the time series of these wonderful orange trees. The first one is bar chart. The second one is scatter plots, line chart, and the last one, the 3D of bar chart. Which one? If you guys answer it correctly, Jae-Kwan will buy you drinks.
Really?
Yes.
Okay,
Which
this
one?
is unscripted, but
Exactly.
okay, so which one now, Sam? Line chart. Okay, so can we go next? So do you guys agree with Sam that the best chart to represent the growth rate of the 5 orange tree is this line chart? Okay, cool. Let's go. So do you think this is a good graph? You can like automatically see that what is this graph about? Oh, really? Oh, okay. Actually, no, this is unscripted. You haven't seen like what is each axis identified of, right? It's quite like too light, so you cannot see the content. But okay, do you think we can improve this graph for a better? Okay, so let's improve it one step. Now you will have the axis identifier that you can see the age in the x-axis, that you know that by the times go by, the day since like that year back in 19 something, yeah, is 100 day, 500 day, 1000 day, 1500 day. And the rate is the circumference in millimeters. But do you think we can improve this graph for a better? Yes. Okay, let's go next. What do we do next? Because you didn't know like which graph identify which tree, right? So then we add the identifier of like tree number 1, 2, 3, 4, and 5. You can see it's divided in 5 colors and also in 5 numbers. Do you think we can improve this graph for better? Yes. Okay, we still go on. So in here, you can see that, okay, can you go back a little bit? Pay attention in here. This is like too far range, right? You have 500 jump to 1000 and 1500. That is not accurate with the graph. So then we add more range to be more specific. Do you think we can improve this graph for a better? Yeah. So we still, so for now, you can see that we measure the times. We measure the growth of the tree for 8 times. So we put the plot for each day that we measure the tongue circumferences. So you can see the day 1, day 2, day 3, day 4, day 5, day 6, and day 7. Do you think we can still improve this graph? So yeah, you can see the pattern. So yeah, so this is the last one. I cannot quote you guys. This is the farthest that we can get.
Okay, so this is the last part, the manipulation part. We want to make the graphs so interactive, aka more cool to show to you guys. So what we add is we add a slider in order to show you guys the first 3 growth rate, the second 3 until to the 5th 3. And last, this is the last but not the least, the conclusion. This chart actually reminds me some things. It's about the success. Success is not determined by the starting point. It's about process, how we live, and how we grow, right? Just according to this chart, as you can see, all 5 different orange trees have the same starting point. But because of different process, it leads to different result. Thank you.
Thank you.
Okay, Club. Leave this on, yeah. Okay, good. Now, what's important about, what is the most important choice implicitly made here? They didn't make it because the data made it for them. But actually, there is a decision. the starting date. In this case, it happens that the starting date is the beginning of your data set, right? But imagine we are talking about, forget about 5 oranges. I'm talking about GDP trajectory of 5 countries, right? In which case, I can do 2 things. I can literally just say GDP of every country, just as a line, right? You will discover real quick that you have to do this. You have to present countries that are of similar size together. Otherwise, you know, there'll be like Moldova here and United States over there, and you can't squeeze them in the same graph. So that's one decision. So the decision is to give the raw GDP number, but in a way that still doesn't, remember one of the objective is that you have to maintain clarity. If you have Moldova here and United States over there in one graph, it's not going to work, right? So you have to say Moldova with Latvia or whatever, let's say. Okay, so that's one choice. The other choice is to say, let's have a visualization based on growth. In which case, everybody gets normalized to say 1979 GDP. Okay, in which case, that's the decision. Because countries didn't start in 1979, right? But I'm looking at 1979. So my 1979 equates Moldova, United States, you know, all Japan, Thailand, every country starts at 100 and then goes on, right? So what would make an interesting case? And this is something I would suggest for you in more econometrics leaning. How about this? Instead of starting with the data that normalizes the fixed date, makes the beginning date your slider, right? So I can actually display the whole, okay? Imagine this data. Now, this is something that you didn't do, but I don't expect you to. But let's say, I'm just going to artificially assume, make the case that these are different countries, right? And this is 1979, this is 2020. What if I do this? I said, normalizing year is my slider. So I can start at normalizing at 1979 and go forward. I can start normalizing at 2020, go backward. I can normalize at the year of the global financial crisis, 2008, right? Right now, one of these is actually being circulated to communicate something very important, not to you guys, obviously, but to British people, right? British people went through what's called a Brexit. So one of the graphs that they did is to compare growth rate, export, all of this. But the normalizing year is the Brexit. So you can see that every country in Europe suffers from COVID and blah, 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 and this and that. But if you normalize everything at Brexit year, you can see that Britain really is terrible compared to the rest of Europe, right? So this would be a really fun chart. I would, you know, even though you've done the homework, that's good, that's fine. Try this. Try to make a live calculation. All you need to do is just have the time series, decide on what's the base year, and just move it, right? So once you move it, so the graph, you can say, this one is by default, start from the left, but you can go all the way to the right and anywhere in between. That would look good. Okay, I would do that. And of course, final lesson to everyone. Please make the line a little bit thicker. Okay, very good, Cap.